So I want to work through an example of how you can use abduction as a way for getting knowledge about the world, this inference to the best explanation. So if you go out and take a look at the night sky and you watch over the course of about a month and you take a look at Mars up there, what you'll see is that over the course of a month, depending on what time of year you take a look at it, Mars will move in one direction, then it will go back in the other direction, and then it will turn around again and start going back in the other direction. So this photo here is of Mars, and each little bright dot is Mars, and a picture of Mars taken on a different night of the month. And you can see it moves from right to left, going one direction, then it turns around and goes back the other, and then it goes back the other direction over the course of a month. And so if you're an astronomer taking a look at this, especially if you're an astronomer a few hundred years ago and you aren't able to, shoot up into space and try and take a look at Mars directly, you might wonder, oh, like what's going on here? How are the planets moving such that this is the observation that I'm making down here on Earth? And if you think about it, really the best seeming explanation seems to be that, well, Earth is at the center and Mars is going around the Earth. Something like this diagram here. So here the red dot is Earth at the center, and Mars is the other little red dot going around the Earth. And then in order to explain why Mars goes in these little loop-de-loops, well, you just assume, oh, sure, so Mars must be not only going around the Earth, but it's also circling around the point that it's circling the Earth on. That's called an epicycle. So if you take a look at that straight line, that's how Mars would look if you're looking from Earth up to Mars. Yeah, you would see it do these little loop-de-loops in the sky. That seems to be the simplest explanation of what's going on. Now, what happened when Galileo and Copernicus came along, they had this idea that, oh, you could actually show that you could see the same pattern even though the sun is actually at the center of the solar system. But if the sun is at the center, it's not clear why Mars would look like it's doing little loop-de-loops around the Earth, because Mars should just be going around the sun just like the Earth, so it doesn't seem like you'd see it doing these little loop-de-loops in the sky. But what they realized is, well, gosh, if Earth is going around the sun closer to the sun and going a little more quickly, and Mars is going around the sun farther away and moving more slowly, then if you chart out the line of sight from the Earth to Mars, from your point of view on Earth, it will look like Mars is doing little loop-de-loops. But it's just that Mars isn't actually going in little loop-de-loops. It just looks like that because of how we are moving relative to Mars when we look up at it in the night sky. And so now you've got two different hypotheses about how the universe is put together. One has Earth at the center, and Mars is going around the Earth along with all the other planets and doing little loop-de-loops in the sky. The other hypothesis is that the sun is at the center of the universe, and Mars and Earth and everything else is going around the sun. And both of those hypotheses explain the observations, the data that we have available. But we want to know, as good philosophers, well, which one of those hypotheses is correct? We want to know which one of them is true. So we've looked at several different strategies over the first part of the term for trying to figure that out. So you had rationalists like Descartes and Plato who thought, well, look, we could just reflect on our own beliefs and use a tool like logical deduction to figure this out. You had empiricists like Locke and Hume who said, no, you just have to go out and get observations and experiences that will tell you what the truth is. And what it seems to be the case in this example and a lot of other examples is that, well, neither of those are really going to get you exactly where you need to be. You cannot figure out how Mars moves just by reflecting on your idea of Mars. Mars is going to move how it's going to move independently of how you happen to think about it. But by the same token, as we've just seen, your mere observations of Mars, your experiences are not on their own enough to distinguish between these two different hypotheses. Those observations are both compatible with the hypothesis that the Earth is at the center and the hypothesis that the Sun is at the center. So just pure empiricism using induction, that's not going to cut it either. So that's why we're now moving to this confirmation holism, abduction, this inference to the best explanation, because that is what folks used to distinguish between these two hypotheses, and it's indeed a pretty good general account of how it is that scientists reason about the world. So you notice, if you try to use induction to try and figure this out, you could say, well, look, Mars sure looked like it was on an epicycle going in loop-de-loops around the Earth last month. It looked like it again today, so I guess Mars travels in epicycles. So that's going to get you the wrong answer. If you try using deduction, you could say, well, it clearly and distinctly appears that Mars moves in these loop-de-loops around the Earth. Then, yeah, I guess maybe God makes it so that whatever I clearly and distinctly perceive must be true, so Mars must move in epicycles. That gets you the wrong answer again. So that's why we want to move to abduction and try to figure out, well, what is the best explanation? Is the best explanation that Mars moves in loop-de-loops, or is the best explanation that actually the Sun is at the center of the solar system and both Earth and Mars are going around? Now, of course, that again brings up this question, well, just what makes one of those explanations better than the other? And that's exactly what Quine and Ulian's article is about that I've given you this week. Their account is to say, look, better explanations are explanations that have these 5 traits. They're more conservative, they're more modest, simple, general, and refutable. So if you've got 2 different hypotheses, 2 different explanations about, say, how Mars is moving, then what you want to do is evaluate those explanations against these 5 virtues and see how they stack up with one another. So we have moved away from this idea that Descartes had as knowledge as this pyramid, where you just kind of take one belief and just build off that one belief up through all of your knowledge, to this idea that I was showing you in the other video, where we think of our knowledge more as a raft. We're lost at sea. And what you've got to do is just take a look at all your beliefs and all of your data all at once and figure out, okay, so what is the most general, the most simple, the most modest way of fitting all of these beliefs together, fitting all of these planks of my raft together? And that is going to be the raft that's going to contain the most true beliefs and lead to the most knowledge. So we're on this raft out at sea. It sure looks like Mars is going in loop-de-loops around the Earth. But on the other hand, gosh, we've got this other explanation that's a little more simple. It doesn't require things to do all of these loop-de-loops. You just put the Sun at the center. And so you might think, oh, well, that second hypothesis about the Sun being at the center, that's a more simple hypothesis. It's got more of that virtue 3. It also seems to be a more modest hypothesis. It's not assuming that there's anything special about the Earth's vantage point, about us being at the center. It just assumes, the Earth, we're just one of many planets that are going around the Sun. It's a general hypothesis. Both of the hypotheses are pretty general. In fact, you can explain the movement of all the heavenly bodies either on a model where the Earth is at the center and lots of things are going in loop-de-loops, or on the model that the Sun is at the center. So they're both general in that they explain the movements of all those planets. They're both refutable. You could come up with evidence that could show that one of them works and the other one doesn't. Now, whereas the Sun-centered model is more simple, the Earth-centered model does have the advantage of being, more conservative, especially if you're, growing up in the 1500s, and most people still believe, come on, the Earth is at the center. We saw all that evidence at the beginning of the tour of why it makes sense to think that the Earth is at the center of the universe. So you've got to balance these different virtues off of each other. So on the one hand, we've got this sun-centric model, which is more simple and more modest. But then at the other hand, we've got this Earth-centric model, which is a little more complicated. It's not as modest, but at least it's more conservative. And, well, you've got to kind of, move the little pieces of your raft around and figure out, well, which of those is best? Which kind of makes sense, the most sense out of all of these different virtues? And so that is the best sort of strategy I can give you. And like I say, I think it's the best characterization of what scientists do. And so you can use this throughout your life to try and adjudicate claims that people are making for what evidence shows is true or false. That's what I'm asking you to do in your assignment this week in evaluating some of these conspiracy theories. I'm fascinated when you go to the Creationist Museum down in Kentucky outside of Cincinnati, Ohio. They have this very sophisticated foundationalist epistemology. They say, look, we believe that the Earth and the universe is only 6,000 years old, as opposed to, scientists, non-creationist scientists, who believe that it's several billion years old. Now, what are our reasons for that? Well, it's because the scientists, they take Descartes' I think, therefore I am, as a foundation and build their tower of knowledge off of that. Whereas we just take a different foundational belief. We take the foundational belief that everything in the Bible is true, and then we just build all our knowledge off of that. So we just interpret all of the same data in light of that foundational belief. And so our reasons for thinking that the universe is 6,000 years old are just as rational and just as good as the reasons that scientists have for thinking that it's several billion years old. It's just that we come from different starting points, and any starting point is just as good as another. And they're right about that if you adopt the kind of foundationalist approach that Descartes adopts. But if you take a more abductive approach and you try and think, oh, right, like what's the best explanation, though, of all of this data? Well, then you get something like this where you say, like, okay, you could just kind of take it as undoubtable that the Bible is correct and that the Bible says the Earth is 6,000 years old and interpret everything in light of that one foundational belief. Or you can do this thing where we're on the raft and, gosh, you just have all of this different evidence and you want to think, look, I'm not going to hold on to any of this as foundational and immune from revision. I'm just going to look at all of it together and try and figure out, well, what's the best explanation of all of this stuff? What is the explanation that's going to be the most simple, the most modest, the most general, etc. explanation of all of these things that I'm observing? And once you adopt that perspective, then you can see why, right, you say what you like about, say, your foundational beliefs in, biblical proclamations about the age of the earth. The better explanation in terms of the five virtues that Quine points out is probably that, the universe is billions of years old and that life evolved through this process of evolution. Now, you could end up being wrong about that. We're never going to have the kind of certainty that Descartes hoped for, but that seems to be, given the current state of our knowledge, the best explanation of all the data. And that's the best I can do for you.